Title of the first section today is Graphing, Systems of Inequalities. First inequality is y is greater than or equal to negative 4x minus 3. Second inequality, y is less than negative 4x plus 1. To graph these inequalities, they're both in mx plus b form, so we can use the slope-intercept form to graph. The first inequality, m is equal to negative 4, the number in front of x, and b is equal to the last number, negative 3. Second inequality, m is also equal to negative 4, and b, the y-intercept, is equal to positive 1. Graphing these two inequalities on a xy axis. The first inequality, the y-intercept, is at negative 3. And the slope is negative 4 or negative 4 over 1. So we'll go down 4 spots and to the right 1 spot. The first inequality is greater than or equal to, so this line would be a solid line. For shading this graph, y is greater than negative 4x minus 3. If y is greater than, we'll shade everything above the line. In this case, it will be to the right side of the line. The second inequality, starting at positive 1 for the y-intercept. Slope is also negative 4 or negative 4 over 1. So we'll go down 4 spots and to the right 1 spot. This inequality is less than, so it will be a dashed line. And the inequality is y is less than negative 4x plus 1. Less than means we'll have these smaller y values, or everything underneath this line, or everything to the left of the line. Since we want everything bigger than the first line and smaller than the second line, the common area is everything that's in between the two lines. And that would be the graph for the inequalities. Title of the last section today is More Graphing, Systems of Inequalities. First inequality, x is greater than or equal to 2. And second inequality, y is greater than 3. To graph these two inequalities, we can draw the xy axis. For the first inequality, x is greater than or equal to 2. If we put a point where x is equal to 2, and the equation x equals 2 would be a vertical line passing through 2. The inequality is x is greater than or equal to negative, x is greater than or equal to 2, so we want the numbers bigger than 2, which would be to the right of this line. Second inequality, y is greater than 3. Again, we'll go on the y-axis up to positive 3. And if it was an equation y equals 3, it'd be a horizontal line going across. Since it's greater than 3, it'll be a dashed line going through 3. And y is greater than 3, we're going with the numbers bigger than 3, which would be above this line. The part that would be shaded in common would be the top right hand corner, would be the common shaded part for the graphs. Second inequalities and last inequalities for the section. 12y plus x less than or equal to 32. And x minus y less than or equal to 6. These equations are in standard form, where we have x and y on the same side. To graph these, we can use intercepts. The first equation, 12y plus x less than or equal to 32. If we plug a 0 in for x, we'll have 12y plus 0 less than or equal to 32. The 0 we can cross off or ignore. So we'll have 12y is less than 32, and dividing by 12, we'll have y is less than or equal to. Reducing fractions, we can divide by 4, and we'll have 8 over 3. Doing the same equation, but this time we'll put a 0 in for the y. 12 times 0 plus x less than or equal to 32. 12 times 0 we can ignore, and we'll have the second intercept, x is less than or equal to 32. So the two intercepts for the first inequality, y is 8/3 and x is 32. If we do the second equation, plugging in zeros, if we do a 0 for x, we'll have negative y is less than 6. Dividing by a negative 1, we'll have y. And dividing by a negative 1 would change the inequality to less than or equal to negative 6. And again, solving the second inequality for the x-intercept, we can plug a 0 for y. X minus 0 is less than or equal to 6, or x is less than or equal to 6. Graphing this equation. The first inequality, the y-intercept was 8 over 3. 8 over 3 is the same as 2 and 2/3, so a little bit less than 3. And x is less than or equal to 32. If we go out to x is 32, the intercept would be at 32. This inequality was originally less than or equal to, so it will be a solid line. We'll graph the second line and then we'll shade afterwards. The second inequality, the y-intercept was at negative 6. And the x-intercept was at positive 6. Again, this inequality was less than or equal to, so it would be a solid line. Last part will be shading. If you look back at the first inequality, 12y plus x less than or equal to 32, we can use a test point for 0, 0. First inequality would be 12 times 0 plus 0 less than or equal to 32. 12 times 0 would be 0 plus 0 would be 0. And we have 0 is less than or equal to 32. This is a true inequality. So the first line that we graphed was this top line. 0, 0 would be the part that's shaded. So this line will shade underneath or to the bottom of the line. Second inequality, x minus y less than or equal to 6. Again, plug in zeros for x and y. 0 minus 0 would be 0. And we have 0 is less than 6, which again is a true inequality. So the second line that we graphed will shade the side with 0, 0, which would be above this line. The side that's in common, below the first line and above the second line, will be the section on the left-hand side. And that would be the graph for the section.